Hey guys, welcome to the video for factoring when a is 1. We are on day 2 in unit 6. Our essential question is, how can I rewrite a trinomial into the product of two binomial factors? So this is just a continuation of when we factored when a was 1 in the previous notes. So we did learn a calculator trick in that one. I'll go over it one time in this video, but after that I probably won't be showing it on camera. But when we talked about factoring, we know that it's the opposite of distributing, right? We're undoing distributing. And so if I started off with these two guys right here, I would multiply these, I would double distribute, and then I would get a trinomial once I combine like terms. But when I'm factoring, I want to go backwards. I'm going to start off with my trinomial, and then I want to make it 4 terms so that I can factor by grouping. And we can only do the grouping if we have 4 terms. Well, in order to get 4 terms, we have to do this thing called the AC method. And the AC method is only doable if I have 3 terms, or if I have A, B, and C in standard form. So we're going to go ahead and jump into today. So we're going to go over and just remember what standard form of a quadratic is. So that is going to be ax squared plus bx plus c, where a, b, and c are numbers. Okay, they don't represent letters, they don't represent anything else. So if I ask you what a is, I would expect the answer like 5 instead of 5x squared. So it would just be a 5, 1, whatever that number may be. Now, before you ever factor, even when you're just factoring a GCF out, or when you're factoring a trinomial, or factoring a binomial, factoring whatever, you always want to look for a greatest common factor first. And if you do not do this at the very beginning, it's not that your answer is wrong, it's just not completely factored. Oops, I forgot to put comma in there. Okay, so we're looking for our GCF first, our greatest common factor, the largest thing we can take out of all of them. Now we're going to review first what we did on day 1. So we're going to first factor our trinomial here. Well, the first thing I always check for is that it's in standard form and that for a GCF. So now that I've checked, I want to see, is this in standard form? Yes. So you always want to check to make sure that the squared is first, then the one that with just a 1 exponent, and then your plain old constant number in the back. So you want to have something squared plus the variable by itself and then a regular number. Sorry, I was grabbing a calculator, so I'm sorry if there was like an echo or any movement there. Now, once I do that, then I check, hey, do I have a GCF? Well, you want to check for all 3 of your terms, or however many terms you have. In this case, we have 3. Now I have 3 terms. Well, what would be the largest number I could factor out? Well, the largest number I could factor out is just a positive 1. Can I factor out any ends? No, because this last guy doesn't have any ends, right? So I can't factor out any ends. So the most I could take out is a 1. Well, is dividing by 1 going to change anything? No. So if I don't have anything except for 1, then I'm good. So if I have 1, I don't really have to say that I'm factoring out 1 because that doesn't change any of the terms that I have. Now, before I can actually do the AC method, I just want to double check, do I have 3 terms? Yes. You can only do the AC method if you have the 3 terms in standard form. If you don't have those 3 terms, you can't do it. You can't do it with 5 terms. You can't do it with 1 term, right? You can't do it with those. All right, so let's do our AC method. And to remind us, our AC method is called the AC method because we do A times C in the top of our X, and we put our B at the very bottom of our X. So in order to do this, we need to identify what A, B, and C are. Well, our A here is 1, our B here is negative 15, and C is positive 54. So A times C is going to be 1 times 54, which is just 54, and then our B is negative 15. And you're like, well, what goes on the sides of those x's? So let's remind ourselves what calculator trick we can use. So the goal here is we want 2 numbers that multiply to 54, but add to negative 15. Now, if you don't know your multiplication facts, this can be a bit of a difficult task, so I do have a calculator trick to kind of help you out here. So the calculator trick, you want to type in AC divided by x in your first y equals, and then AC divided by x plus x. Okay, so once you type all of that in, I will do that in a second, you're looking at your table, and you're looking for a certain number. So you're going to have a table that looks like this when you go to your graphing table. Your goal is to try to find negative 15 in the y2 column, and that's typically going to be our red column, okay? So we're looking for it in the y2 column, and we're trying to find those 2 numbers right here that add to negative 15 but multiply to 54. So again, we're going to type in AC in our calculator and the y equals. Now notice that AC here is 54. So I'm going to switch over to my camera real quick. And I'm going to get my calculator ready. Sorry, I know you're just seeing a blank screen right now. And I'm going to be holding my calculator, so it might be a little shaky. All right, so the first thing I'm going to do is type in AC divided by X. Well, again, AC was 54, so AC divided by X. And then we do 54 divided by X plus X. All right? And then we're going to hit second graph because table is in blue, so to get to it, we would have to do the second button. Now, our goal here is to find negative 15 in the Y2 column. So it looks like, I notice that my numbers are getting more and more smaller negative. So like they start off really high negative, negative 55, negative 29, and I want negative 15. So it looks like if I go up one more, I'll probably get there. All right, so we're looking for negative 15 because that's our B value. So our two magic numbers are negative 9 and negative 6. Now, it doesn't matter which one you write in which part of your X. So if you want to write the 6 first, you can, or you can write the 9 first. I'll go ahead and do what the calculator says, negative 6 and negative 9. Again, it doesn't matter. You'll get the same answer regardless of the order. And I'll talk about what happens if you do flip the order around. All right, so let's go ahead and rewrite our trinomial into 4 terms now that we can split up. So why do we do the AC method? Because we're trying to get our trinomial to become 4 terms. So then we have n squared, and then 54 stays the same. We're just splitting up our middle term into 2 separate terms to negative 6n and negative 9n. Now once I'm at this step, I want to go ahead and factor by grouping because I have 4 terms. So I'm going to split this down and make 2 groups. In my first group, I have these 2 terms. Well, the largest number I can take out is 1, and the most amount of n's I can take out is just 1n. So if you want to write the 1 in the front, you can, but I'm not going to. And if that helps you, you can go ahead and do that. So we have n, and then we have left over n minus 6. Because if I have 2 n's and I take away an n, I have 1 n left. And then negative 6 divided by 1 here is just negative 6, and these n's actually end up canceling. All right, and then between our next 2 terms here, the largest number I can take out of both is 9. Now you're like, I don't remember how to do that trick quickly because I don't know my multiplication facts that well. So if you notice, we have 2 numbers here. We have 9 and 54. Now I notice you're probably saying, well, that's a negative 9. It doesn't really matter if it's negative or positive because if I'm just trying to find factors, then the negative doesn't really matter. The negative only matters is when I take it out at the bottom here. So if the first term in your group is negative, you want to make sure you take out a negative. But when we type it in our calculator, we don't need to say negative 9. So I'll show you what I mean by that. Let's say we're trying to find factors of 9 and 54. Go ahead and clear these. So if I want to try to find factors, I would do 9 divided by x, and then 54 divided by x. Now this calculator trick is different from the previous one. Now here I'm looking at my 2 columns and I'm going to look for the biggest number that they have in common. So I'm going to go to the positives because that helps me a little bit more. Negatives are kind of freaky sometimes. I'm looking for the largest number that they have in common. And it looks like the largest number that they both have in common is going to be positive 9. Now I noticed that I had 9 in pink there, but I added that negative because that first term is negative. But if this first term was positive, then I would only need to take out positive 9, okay? So only if the first term in your group is negative. So I'm taking out negative 9. Well, negative 9 divided by negative 9 is positive 1, so I have positive 1n left, and then 54 divided by negative 9 is negative 6. And before you move on, you want to check to make sure your parentheses match. And they do. So we put our GCFs in one parentheses, whoops, so we have n minus 9. And then on our second set of parentheses, we have the matching n minus 6. So that's where those come from. And I'll go ahead and actually color code this differently so that we can see that a little bit better. We'll use pink to help us out a little bit. Now you're probably being like, well, what if I put negative 9 first and then negative 6? And so my order is flipped around. That's perfectly fine. You actually get pretty much the same answer. It's just kind of worded, or not worded, but arranged differently. So instead, you might have 9 minus 6, or not 9 minus 6, n minus 6, and then n minus 9. But they mean the same thing. Same answer regardless. So it doesn't matter the order. We're still multiplying them. Okay, so that's what we did on day 1. We factored by grouping with our 3 terms here for the first time. I'm not really sure. There it goes. I was like, oh, why is it doing that? So again, we went ahead and we did that day 1. So far, when we have looked at all of our trinomials, we have not had a GCF other than 1. Well, what happens if we have something other than 1? So let's take an example, or let's look at this example really quick. So we're going to distribute. Now, distributing, again, is the opposite of factoring. So this isn't what we're doing. This is what we did in Unit 1, and we're going to undo all of this in a little bit. So we're going to distribute this first. So I taught you something in the last set of notes called double distribution. So for now, let's just go ahead and leave this 3 off for a second, and let's just double distribute our parentheses. So we have x times x, which is x squared, and then x times negative 1, which is negative 1x, 2 times x, which is positive 2x, and 2 times negative 1, which is negative 2. Now, I haven't done anything with that 3 yet, so I'm going to leave it out there. Now, before I move on, I want to check for any like terms inside my parentheses. And I do. I have negative 1x and positive 2x. So that's going to be x squared plus 1x, or just plus x, minus 2. Okay? Well, I'm almost done. I can't combine any more like terms, but there's one last thing I haven't done yet. I haven't distributed the 3. So let's go ahead and do that in this step. 3 times x squared is 3x squared. 3 times x is going to be positive 3x. And then 3 times negative 2 is negative 6. So that's my finished trinomial. I can't combine any more like terms, and I've distributed all the way. So since I just distributed and got all of that combined, how do I undo all of this? Well, in order to undo all of this, I would need to factor. So in order to undo this, I would have to do it by factoring. So that's going to lead us into our first example. 3x squared plus 3x minus 6. So the first thing you always check for is, again, you want to make sure it's in standard form, but you also want to check, hey, do I have a GCF other than 1 this time? So if it's just 1, we don't have to really divide anything out because that doesn't change anything. Okay, well, I look, it is in standard form. Do I have a GCF? I do. What is the largest number I can factor out of all 3 of these? A positive 3. Okay, now can I factor out any x's? No, because this 6 doesn't have an x. So the largest GCF, or the largest thing I can take out, is my GCF of 3. So then I'm going to factor 3 out and then put the rest in parentheses. So I'm going to have left over x squared plus 1x minus 2. Okay, now you're probably like, okay, so we're undoing that, so now what? Well, now I just want you to kind of not really forget about it, kind of make a mental note at the bottom, hey, our GCF was 3. And there's a reason why I'm writing that down there is because we typically forget about that. So for now, I'm going to forget about it and just pretend like it's not there. Now just look inside our parentheses here. How many terms do we have? We have 3. Now, could I make these 3 terms become 4 terms by grouping? Yeah, and in order to do that, I would have to do the AC method. So AC would go on top and B would go on bottom. Now, in order to do this, I need to identify A, B, and C first. My A here is a 1, B here is also 1, and C is negative 2. Okay, now you're like, well, what about the 3? Isn't that A? That's our GCF. So just pretend like it doesn't matter right now. We're just looking inside these parentheses. So pretend like it's not there. All right, so we would do A times C, which is 1 times negative 2. That's going to be negative 2. And then our B is going to go at the bottom. Once we do our calculator trick, when we find our 2 magic numbers, we should get positive 2 and negative 1. Okay, and that makes sense. 2 times negative 1 is negative 2, and 2 plus negative 1 is positive 1. So now we're going to split up our trinomial into here into 4 terms. And you're like, well, where did the 3 go? It's still there. I'm just leaving it off for now so that it doesn't confuse us anymore when we're doing our math here. So we're going to split up our x and make it 2x minus 1x, and then we still have minus 2 here. Ugh. Sorry, it's bothering me that the arrow looks crooked. Okay. So, again, all we're doing here is we took out the 3. We're going to leave it alone for now. We're just going to treat it like it's a regular trinomial. So now we're going to factor by grouping. So let's do blue first. The first thing I see is my GCF here is going to be just 1x. So I'm going to take out 1x. So I have left in the inside 1x plus 2. And then I'm going to do my GCF of the next 2. Well, here I would have 1 is the biggest number that goes into both. But I would take out -1 because the first term is negative. Okay, so I'll have -1, and then I'll have x left over plus 2. Now again, if your 2 and your -1 are flip-flopped, this part right here might look different from mine, and our answers will be backwards, but it'll mean the same thing. So that means my matching parentheses are x minus 1, and not matching parentheses, my GCFs will be x minus 1, and then my matching ones are x plus 2. Now I haven't mentioned this yet, but these are called factors. So one of my factors is x minus 1, and the other factor is x plus 2. So those are also called factors because we're factoring, we're trying to get the things that multiply to make our original answer. Now, is this my answer? Is this my final answer? Well, let's check. We just tried to undo this problem, right? Like we started here. We started right here because we're trying to undo this problem. So if I were to undo this problem, I should end up with this. So let's look at that. I'm going to highlight this, and then I'm going to highlight our answer. What's wrong? What's the difference? Well, it looks basically the same, right? Because again, that's the same thing as x plus 2, x minus 1. It looks exactly the same, but what are we missing? We're missing this 3 here. Well, where do you think that 3 came into play? That 3 is the thing that we took out at the very beginning. So that's why we don't want to forget about it, because it's a crucial part of our final answer. Okay, the GCF, it is a little bit, it's just in the way if we write the 3 at the outside the entire time. So that's why I just want you to remember, hey, we took out a GCF at the very beginning, so just make a note to yourself, be like, hey, I took it out. So that means that when you write your final answer, you don't want to make the mistake of being like, hey, I factored, I'm done, this is my answer, right? Because you want to make sure, be like, hey, did I take out a GCF? And you want to make sure you write that as well. Okay, and then how could I check this? Well, I could double distribute and then put distribute the 3 in, and I will end up with what I had at the very beginning. All right, so we're going to go ahead and try this with the next example. Number 2, you want to check to make sure it's in standard form. And then the next thing you want to check for is, do you have a GCF? Now again, if you don't know how to find factors, this is when you would use the calculator trick to find factors. So you would do 4 divided by x, 20 divided by x, and 24 divided by x. Again, the negatives don't really matter here because if the first term is a negative, then I don't really care about typing in negatives here. So you can do that if you need to find factors. But I know that I can factor something other than 1. I can factor out a 4. Now because I can factor out a 4, I need to take that out. So on the left, on the inside, I have x squared minus 5x minus 6. All right? So now before I actually move on here, I want to check. On the inside of my parentheses, do I have a trinomial? Yeah, that means I can do the AC method. So I am going to make a note to myself that I took out a GCF of 4 at the very beginning, and then I'm going to go ahead and move on with what I have left, right? So we're going to do our AC method. Okay, well, A here is going to be 1, B is -5, and C is -6. Again, A is 1. The 4 is the GCF. It's not 1 anymore. Okay, you want to look at this guy. You don't want to look at your original. All right, so A times C is going to be -6, and B is -5. My 2 magic numbers there, if I were to find this in the calculator, would be -6 and +1. -6 times 1 is -6, and -6 plus 1 is -5. So if I were to split this up, I would have x squared, and I would have -6, and I would split this up and make it -6x plus 1x. And again, you can flip-flop it around, so it doesn't have to be in this order. So I'll go ahead and do that just to show you that you would still get the same answer even though I flip-flopped it around. So the first thing I'm going to do is split this down the middle so I can factor by grouping. And then I'm going to find the GCF of the first 2 terms, which is just 1x. And on the inside, I would have left over x plus 1. And then I would do the GCF of the second 2 here, and I'll go ahead and move this. Oops. I'm going to move this to the side just so that I have some room. Now, if I have -6x and -6, the largest number I can factor out is -6. If your 2 numbers are the same, that's the largest thing you can take out. Now, why am I taking out a -6? Because the first term in my group is negative. And left over, -6 divided by -6 is just +1x, because I still have the x left over because I didn't take it out. And then -6 divided by -6 is +1. So one of my factors is x minus 6, and the other factor is x plus 1. But is this my answer? No, because if I were to double distribute this, I'd be missing something, right? I factored out a 4 at the very beginning, so we want to make sure that we don't forget that we factored that out. Because this is factoring. We're undoing literally everything. And the first thing we undid was the 4, so we don't want to forget that we undid that first. All right, so starting off with number 3, we have m squared minus 7m minus 18. Do I have any GCFs? No. The largest number you can factor out is a positive 1. So I can't take out any numbers. And I can't take out any m's, so I don't have a GCF other than 1 here. So that means I don't have to worry about the GCF at the very beginning like in this problem. I can just move on with my day. Since this is 3 terms, I know that I can try to factor by grouping. Okay? So let's factor by grouping. We're going to have A, C, and we're going to have B. Identify A, which is 1, B is negative 7, and C is negative 18. A times C is 1 times negative 18, which is negative 18, and B is negative 7. Now, A is not always going to be 1. It is 1 in this lesson, but it's not always going to be 1. You're looking for your 2 magic numbers, so in this case, you want to make sure you're typing in y equals negative 18 over x, and y equals negative 18 over x in parentheses plus x. You're looking in your table. Whoops. You're looking for negative 7 in this column and to find those 2 magic numbers. So that would be a negative 9 and positive 2. So we're going to have m squared and then negative 18, and we're going to have negative 9m plus 2m. All right. So we're going to again split this down the middle, make it 2 groups because we're factoring by grouping. Find the GCF of the first 2, 1m, and we have m minus 9 left. Here I would factor out a positive 2, not a negative 2. Just because this one's negative doesn't mean I factor it out, only if the first term in the group is negative. So this would be positive 2, and then I would have m minus 9 left over. And so one of my factors would be m plus 2, and the other factor is m minus 9. Is this my final answer? Yes. I didn't have a GCF other than 1. Now, you can write the 1 at the beginning, but it's kind of like a waste of space, right? You don't need to write that 1 there because multiplying 1 isn't going to change anything. Number 4. So, let's look. It's in standard form because it goes from the highest exponent to the lowest exponent. Do I have any GCFs? I do. The largest number I can factor out of all 3 of these terms is positive 4. Can I factor out any x's? I can. Now the first one has 3 x's, the second one has 2 x's, and this one has 1 x. So the most amount of x's I could factor out is just one of them. So our GCF this time is of 4x. It's not just a number. And then we're going to put over our leftovers in the inside. So 4 divided by 4 is 1. And if I have x cubed and I divide out an x, then I have x squared left minus 5x. And then this is going to be minus, I'm not 100% on what that is. 144 divided by 4 is negative 36. And those x's will cancel each other. All right, so again, just make a note to yourself that you do have a GCF of 4x, okay? Because if you write your final answer and you forget about it, you're going to be missing a crucial piece, right? A very, very crucial piece. And the reason why we want to take out a GCF is because it makes our job a lot easier. It would suck that I would have to do A times C here with 4 times 144. That number would be huge, right? So we're taking the GCF out because it makes our life easier. So I have 3 terms on the inside of my parentheses. AC goes on top, B goes on the bottom. A is going to be 1, B is negative 5, and C is negative 36. A times C is going to be negative 36, B is negative 5. Our 2 magic numbers here are going to be negative 9 and positive 4. So I'm going to go ahead and rewrite my trinomial. X squared and negative 36 stay the same, but I have negative 9x plus 4x on the inside. I'm splitting that into 2 parts, right? And then I'm going to go ahead, group it, and factor by grouping. So I have 1x I can take out, x minus 9. The largest number I can take out is 4. I can't take out any x's because the 36 doesn't have any. And I would take out positive 4 since that first term is positive. My parentheses match, so I am in good shape so far. So then I have x plus 4 as one of my factors, and x minus 9 as one of my factors. Is this my final answer? No, you want to make sure you have that GCF at the front, because if I distribute, I'm going to be missing, again, a crucial piece of that factored form. All right, moving on. So we have 3 left. If you need to take a short break, I would recommend taking a short break. Now, number 5, check that it's in standard form, and it is. The next thing I want you to look at is, do I have a GCF? So I'm going to give you a couple of seconds to think about that. Okay, I do have a GCF. Now you're like, well, I don't see anything because I can't take out anything other than a 1, right? Well, you're like, the largest thing I can take out is positive 1. But that's not true because your first term is negative. So you have to take out a negative 1. And negative 1 does change things, right? That changes our signs. So we do want to take it out. It's not like a 1 and it doesn't change. Negative 1 does change things. Now, if I factor out a negative 1, then all of my signs basically switch the other way. Negative w squared divided by negative 1 becomes positive w squared. Negative 16w divided by negative 1 is going to be positive 16w. And negative 60 divided by negative 1 is positive 60. So our GCF from the very beginning was negative 1. Okay, so let's go ahead and do the AC method here. And I can do that because I have 3 terms left, right? Pretend like that 1 isn't there. A here is 1, B is 16, C is 60. AC on top, B on the bottom. A times C is 60, B is 16. I'm trying to find 2 numbers that add to 16 but multiply to 60. I came up with 6 and 10. All right, so that means I'm going to have the first term stay the same, right? Because we talked about it in the first day that those aren't changing and the last term isn't changing. It's your middle term that needs to split back up because when we distribute, we combine those like terms, and that's how we get that middle term there. All right. Next thing we do is I'm going to split this into 2 groups, and I can do that now because I have 4 terms. I can factor by grouping. Divide out my first 2 terms. The largest thing I can take out is w, okay, 1w. You can write the 1 if you want to. So then I have w plus 6, and then my GCF of the second 2 would be positive 10. So it would be w plus 6 again. Make sure your parentheses match. They do, so we're in good shape. We have w plus 10, and we have w plus 6. Is this my final answer? No. Remember, you pulled out a GCF at the very beginning, so you want to make sure that that does not fool you just because you're like, oh, hey, I'm finished. I did all the work. Cool. All right, number 6. Negative 3x squared y minus 6xy plus 24y. First thing you check for, you make sure it's in standard form. It is. The next thing you want to look at is, do I have a GCF I can take out other than 1? And I can. The largest number I can take out is positive 3. But what do you notice about that first term? It's negative. So I need to be taking out a negative 3. The next thing I want to look at is, can I take out any x's? No, because this last term doesn't have any x's. Can I take out y? I can. All of the terms have y, so I can take out a y as well. So we're going to take out negative 3y. Okay. Now, if I take out negative 3y, what do I have left on this inside? Well, negative 3 divided by negative 3 is just 1, so they cancel. I still have the x squared left because I never took out any x's, and then the y's end up canceling each other. Okay. Negative 6 divided by negative 3 is going to be positive 2, and then the x is going to stay because I didn't take any out, and these y's end up canceling. Then I have positive 24 divided by negative 3, and that's going to be negative 8. And the y's cancel because y divided by y is just 1. All right, so now I have a trinomial. Again, I want to make a mental note to myself, that I have a GCF of negative 3y from the very beginning. All right. So, AC here in B. Identify our A, B, and C first before we do anything. A is 1, B is 2, C is negative 8. A times C is going to be negative 8, and B is positive 2. We're looking for two numbers that multiply to -8 but add to 2. And that's going to be 4 and -2. So we're going to have our x squared and our -8 still, and then we'll have positive 4x minus 2x. I'm going to group this now that we have 4 terms. Divide out a GCF from the first 2 terms. Again, hopefully you're recognizing that this is literally the same thing over and over again. It's just that our numbers change around. Now this time I would take out 2, but I would take out -2 because that first term in the group is negative. And then we would have left over x, and then -8 divided by -2 is positive 4. We have x minus 2 for one of our factors, and x plus 4 as the other factor. I'm going to make sure that that's not our final answer because we did take out a GCF at the very, very beginning. All right, so we have one problem left. And I do have this problem in here for a reason, so I know that you're like, oh, this is the same thing. Make sure you stay for it because it is a little bit different from the previous. First thing you check for, you make sure it's in standard form. You have 3 terms there, they're all in standard. And then you want to check for, hey, do I have a GCF? And I do. The largest number I can factor out is a positive 4. Can I factor out any x's? No. That last term doesn't have any x's, so that means that when I factor, all I have left is just the 4. Right? Well, not left, but the only thing I factor is the 4. 4 divided by 4 cancels. I have x squared plus 3x, right? Because 12 divided by 4 is 3, and I have the x left over plus 5. All right, so now you're like, okay, same thing as always, right? GCF is 3, so let's look at that. I mean, not 3, 4. And then you're like, okay, let's do AC method. Whoops. AC on top. B on the bottom. Our A here is 1, B is 3, and C is 5. All right, well, what's A times C? Positive 5. What's our B? 3. I'm trying to find 2 numbers that multiply to 5 but add to 3. So I'm looking for 2 numbers that go in here. Well, if I do the calculator trick, I would do 5 divided by x, and then y equals 5 divided by x plus x, and I would look on my list. However, when I do this, it's not possible. I can't find 2 numbers that are going to be my magic numbers that will add to this. Right? I'm trying to find those 2 numbers, but I can't find them. And I'll show you. So I'm going to go ahead and switch over to the calculator and do this trick for you. Okay? So I would have 5 divided by x. Whoops, wrong line. 5 divided by x, and then 5 divided by x plus x. Now I'm looking for positive 3 over here. I notice it goes from 6, goes down to 5, down to 4, 4.5, and it goes back up to 6 again. Oops. Oh, it's graphing it now. Oh dear. Okay, well that's going to take a while. My main point is it's not possible for me to find 2 numbers. So well then what do? It just means it's not factorable anymore. The most I could factor was a GCF. That's the largest thing I could factor out, and I couldn't do anything after that. That means I'm done because I can't factor the inside anymore. Okay? The trinomial is not factorable. So that means my final answer was that I factor out that 4. You can't keep going. Well, you're like, well, what if all I have is that? Like, what if I didn't have that 4? And I just started off with the problem that was like this, and it said, hey, factor. Well, if it asked me to do this, and I do my calculator trick, and I see, hey, it doesn't even work, then that would be my final answer. It's not factorable. I can't actually factor it. So again, you factor as much as you can. So in the last example, in number 7, the most we could factor out was a 4, but I couldn't keep going. I couldn't factor by grouping because I could not find those 2 numbers. So that is why I have that last example in there. If you have any questions, just please feel free to come in for tutoring.